Can you guys see my screen? Hello.
Yes, sir.
Yeah. So we understood about in the previous class what we understood. So we understood about the three equations of motion, and yeah, so we understood about the three equations of motion, and yeah. And the other one was my voice is not clear. So my voice is not clear, guys.
No, sir, it's good.
Is it clear now?
No, sir, now it's not.
Now it's not clear. Hello, am I audible now here?
Yes, sir,
Yes,
it's
sir.
clear.
Okay. So these were the three equations, right?
Yes,
These
sir.
were the three equations, and one more equation was there. The distance traveled in, let's say, t seconds, right? So this we calculated to be half a and t, or this was what, t minus half. So this was a t minus, right? This was the distance traveled in the nth second or t. Right? These equations we learned in this class. And also we proved these equations using the calculus analogy. Right? So we used this one, and we also used the acceleration. So what one crucial point was that the acceleration was uniform, right? So these scenarios are, these equations are valid only for the uniform motion, uniform accelerated motion, when your acceleration is constant. Right, guys?
Yes, sir.
Yeah, so the next topic is, I will talk about the graphical solution when we'll talk about this free fall. So what is free fall? Right. So this is an example of uniform acceleration. Right. So let's say that an apple is falling from the tree, right? Or let's say that somebody is throwing some ball downwards, right? So these are the some examples of the free fall. In free fall, what happens is that the force due to gravity, right? So the earth pulls those objects towards itself, and the acceleration that it applies is called the acceleration due to gravity. So that acceleration is constant, so that is why it is called the form acceleration. Okay, so whenever
Sir,
some,
acceleration is constant in all cases for free fall?
yeah, so in all cases, when you neglect the air resistance, so then acceleration due to free fall, only due to free fall or due to gravity. So
Okay,
that is constant.
okay.
Yeah. So, but when you apply some external forces, right, then the acceleration would be reduced. But whenever it is free falling, right, without any external agent, right, so then that kind of motion would be called uniform acceleration. And the acceleration which is acting on that object or the material is the acceleration due to gravity, right? So let's say this is the surface of the earth and you throw some object, right? So this is going, the earth is pulling it downwards, right? and you are throwing some object in the upward direction. So what will happen is that, let's say that you provided some initial velocity, right? And then you throw this object in the upward direction. But Earth is pulling it downward, so the acceleration is in which direction? Yeah,
Towards the Earth.
towards the Earth, right? So this is the acceleration, right? Acceleration due to gravity. So it acts towards the Earth. Always it acts towards the Earth because the gravity is pulling kind of nature. So gravity is attractive force, right? So it always attracts other mass or other objects. So acceleration due to gravity, right? It is represented by G, and its value is 9.8 meter per second square. So this is constant, right? For now, you will find that it is constant, but in higher classes, you will learn that this is not constant. But for now, for the time being, just consider that this is constant. Okay. So this is called the free fall. Whenever somebody is thrown upwards or whenever a body is thrown downwards, so only the acceleration which is acting on that body is gravitational acceleration, and then the body will be said in free fall. Is that clear to you guys?
Yes, sir.
Yeah, so let's say that you throw this body upwards, but it is working against the gravity, right? You have thrown some object in upward direction and it is working against the gravity. So at some point, what will happen is that the speed of this object will be zero, right? Because the Earth is pulling it downwards, right? So its speed is decreasing, right? Why? Because it is feeling some retardation.
Yes, sir.
Okay. So whenever there is a retardation, then the body will stop, right? So we have some example of retardation. Let's say that you apply some brake on some vehicle. So a vehicle is moving and then you apply some brake on the vehicle. So the acceleration is positive or negative?
Negative.
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 Negative. So whenever acceleration is negative, then it is called the retardation. And for the retardation, your final velocity would be zero, right? Is that clear to you guys?
Yes, sir.
Yeah, so
Yes,
we have two convention for the acceleration due to this gravity. So whenever somebody is acting against the gravity, then this is negative. And let's say that you are on some, let's say you are on a roof, right? And then this is some building, right? And then you throw some object from here. Okay. So now this is working against the gravity or in the direction of the gravity?
in the direction of the gravity.
In the direction of the gravity. So then in this case, the acceleration will be positive. We should write it. Is this thing clear to you? We have a free fall
Yes.
whenever the body is acted upon some acceleration due to gravity. So that is free fall. And then there are two scenarios. One is that you are working against the gravity, so then your acceleration would be negative. And then the other case is that you are working in the direction of the gravity, so then your acceleration would be positive, right? So this is the right. Whenever the body is acting, whenever the acceleration is due to the gravity, and the body is moving in that gravitational field, so that is called the free fall. And we have two scenarios. One is against the gravity, the other one is in the direction of the gravity. For the case of the against the gravity, G is negative, and for the case of G in the direction of gravity, G is positive. Okay. Now let us understand these two scenarios. So against the gravity. Right. So we have this body and we have just thrown it upwards. And we have three equations of motion. One is V equals to U plus AT. The other one is this S equals to UT plus half AT square. And the third one is V square minus U square equals to 2A. Right. So what are the initial conditions that we have? So whenever we throw some object, right, with some speed, so we provide some initial speed. That is why it will go upward, right? It will not go upward when we don't provide any speed. So to throw this object upwards, we have to provide some initial speed. So in this case, what are the initial conditions that we have? That you are providing some initial velocity, right? And then what you have acceleration. So acceleration is how much?
Minus 9.8 meter per second square.
Yeah, minus 9.8. Let's say, let's write it as minus g. Okay. And this is the initial condition. At this point, whenever it reaches this point, right, it is working against the gravity. So it is facing some retardation, which means that it will stop at some point. It will stop at some point and then fall again, right? So you throw some object upward and at some point it will fall back, right? So why it falls back? Because its velocity becomes zero. Now nothing is moving this in upward direction, right? So nothing is moving this object in upward direction because its speed has become zero. So now what will happen, that only the acceleration due to gravity is working on that object, right? So it will pull this object backward again, right? So that is why it will fall again. So first thing is that it will reach here. So whenever it reaches here, so what would be the final velocity?
Zero.
Final velocity, right? So we have final velocity is zero, initial velocity is u, this is a. Now let's say that it takes t time to reach here, right? T times to reach here. So let's say that, okay, these are the conditions that we have. Now let us use all these three equations and then we get what are the values that. So V is equal to U plus 8. Right, V is how much?
Zero.
0, U is U, right? And A is minus G and then T. Okay, so U goes in this direction and then G and T. So what you can do is that you can calculate T, which would be U by G. Understood? So you can calculate how much time it will take, right, to reach the highest point. Is that clear to you guys?
Yes, sir.
Now let us use the second equation. So S equals to QT plus half into square. So let's say that it has reached this height. So S is some height. Okay, it has reached some height. So what is that? So S is H, right? So S is using first equation and then using the second equation, QT plus half A T square. Right, so this is H and
Sir,
this is, yes,
we have to use all the equation.
No. So they will give some things to calculate, and then you will have to find out that. So depending upon the question, what they are asking, whether they are asking that calculate the height, right, or
Okay.
calculate the time or whatever they want us to calculate.
Okay,
Okay,
sir.
so yeah, so we want to calculate this h. So this is also in here. So using this equation would be easy, right? So let us use this. So b square,
So the first equation can only be used to find the time.
yeah. So let's say that the time is given, right?
Yes,
Let's
sir.
say that time is given and they want us to calculate that with how much speed you have just thrown that object. So let's say that
Yes.
the question is like that a body is thrown, right, and
Yes.
upwards, and it reaches the maximum height in 5 seconds.
Yes, sir.
So calculate the initial speed that it was thrown. So this could be the question, right?
Okay.
So in this question, they are asking about the initial speed. Or they can also ask this question that a body is thrown upwards, right, with some initial velocity 20 meter per second. So calculate the time it takes to reach the highest point, right? So
Okay,
in
sir.
this case, they are asking about the time. So we will do all kinds of questions. Okay.
Okay, sir.
Yeah. So this equation is needed to calculate the time and initial. Now let us talk about this equation. So V is 0, U is U, A is minus G, and S is H. So minus minus cancel and U is 2G. Right. So you can see that in here you can also calculate H, which is U square by 2G. So this is the height that it will attain whenever we will throw it with some initial speed u. So is this clear to you guys? Yes.
Yes, sir.
Okay, so you guys note down from here and we will do some questions. So this is only against the gravity and we will see the in the direction of gravity motion also. The result will,
So what about the second equation?
yeah, so second equation, we only want to calculate the height and the initial speed or time. So we have already calculated the time, the height, and the initial speed. So we don't need to calculate or we don't need to use this second equation, right?
Okay, sir.
Okay, so we can also see from here that whenever we plug in the value of t, so we can see from here also that h is ut plus half a t square. And we know that t is u by g. So this is u and this is u by g. And this is minus g, right? So half of g and this is how much? So this is u square by g square. So g cancel and u square. So u square by g minus u square by 2g. So you will get what? U square by 2g, right? So you will get the same answer like this.
So it's used for finding the height, right? The body reached.
Yeah, so we can use this equation or this equation, but this is the simpler one, right?
Okay, sir.
So in both the cases, you can see that the height is important, S and S, right?
Okay, yes, sir.
Yeah, so we can use both the equation, but we know that this B is simpler one because it is zero. So the using the third equation would be the easy one. Is that clear?
Yes, sir.
Yeah. So let me, yeah.
So what if they tell to find the speed?
Yeah, initial speed.
Yes, sir.
Yeah,
The first
so
one.
yeah, so whether they will give the time or they will give the what the height. So
Yes, sir.
yeah. So we will do all kinds of questions. Okay. Yes, so whenever you guys need me to just remember this convention. This is important. Okay, whenever we are going against, so this would be negative. We are whenever we are in the direction, so this would be the positive uh, gravitational activation. Okay.
Yes, sir.
Whenever you guys need me to scroll down,
Done, sir. I wrote, sir.
we have Rishita and Amna and yeah, so Akib is not here and
Even I wrote, sir.
we have Rishita. Amna, what about you?
Done, sir.
Yeah. Okay. So now let us think about the other scenario. So in the direction of gravity. Okay. Meaning you are dropping something, right? Dropping drops. And this was what? It was throwing upwards. Okay. So in this case, what happens is that we are dropping this object, right? From here and yeah,
So, free fall is also in the direction of gravity only, right?
yeah, so free fall meaning that you are working in the presence of acceleration due to gravity. So free fall means only that. And whether you are throwing some object upwards, so you are working against the gravity. And
Yes,
whenever
sir.
you are throwing the object downwards, so then you are working in the direction of gravity. So, but free fall means that you are working in the presence of the acceleration due to gravity. Right? Free fall means by that. Okay. And no other forces are involved. No electrostatic force, no other kinds of forces are involved, only the force due to gravity. Right?
Okay, sir. Yes.
Earth is pulling some object down. So that is the fall meaning not it is falling. Free fall meaning that it is placed in the presence of some gravitational acceleration. Right.
Okay, sir. Okay.
Yeah. So now it is when you drop this object, right? So what are the initial conditions that you
Sir, is U equals to 0 in this case?
Yeah, so you just you are placing this object and then throw it down, right? So u is yes, good. So u is 0, and let's say time it takes to just strike the ground. So just reach here. Okay, so this object has reached here, and then it will have the maximum speed that at which it strikes the ground, right? So then your let's say the time it takes it is t and t is right. And what are the other conditions that you have? And G is what? Oh, A is what? G. Okay. So these are the conditions that you have, and let's say S is H. So these are the 5 conditions that you have. Okay. Now again using all the, not all the equation, but the 2 equations. So we have V is equal to U plus AT. And the second one, let's say use the third one, b square minus u square is 2b. So using the first one, we'll get the same result. Okay, so using the first one, b is b, u is 0, and a is g, and time is t. So t is how much? This is b by g. Okay, and then you have using the third equation, right? So this is v square minus u square, this is 2, and gh. So this is 0, so v square is 2gh. So v would be 2gh. Okay, so from seeing this part and from seeing, yeah, so let's say this is whatever one you want. Let's say this is star, and let's say this is some time. So seeing this equation and seeing this equation, what can you guys infer? So u is root 2gh and v is root 2gh. You know that this h is same, right?
Yes, sir.
So what can you say about this v and u? Yeah. Okay, let me. Okay, so I will not.
They are the same, sir?
Yeah, they are the same, right? So whenever you throw, oh, who got disconnected? So Amna got disconnected. So whenever you throw an object with some speed u, right? So whenever you throw the object with some speed u, and when it falls back, right? So it will have the same velocity with which you just thrown this object. Is that clear to you guys? Yeah. Is that
Can
clear?
you repeat again?
Yeah. So let's say that you throw this object with some initial velocity u, right? So it will reach here at its maximum height, and then its velocity would be 0, right?
Yes, sir.
So when its velocity will 0, so now the gravitational acceleration will act on it. So it will pull back this object in the downward direction, right? Now its speed has become 0. Initial speed has become 0. Now it starts to drop, right?
Yes, sir.
So now it will strike with some velocity on this ground. Right? It will strike with some velocity on this ground, and that velocity would be equal to what? So that is what I was inferring in asking this question.
So, sir, V will be equal to U.
Yeah. So whatever speed you throw the object, it will strike the ground with the same speed. This is the analogy. Understood?
Yes, sir.
Yeah. So I will talk about these two conditions in a moment. So just keep in mind that. You guys first note it down, right?
Yes, sir.
And then I will talk about it, right? Because up to this point, what we did was that we just saw that what happens when we throw this object upward, and what happens when we throw this object downwards. Now what we will see that we have thrown this object upwards and then it falls back. So throughout this journey, then we will see what happens. What is the time and what are the other things? Okay. Yeah, so you guys first note it down, and whenever you guys have any doubt, you please ask. Okay, we will do 3 questions. So first we'll do the upward, then we'll do the downward, and then we'll do the mixed question. In mixed question, what we do is that we throw it upwards and then it falls back. So that is the mixed question.
Done, sir.
Yeah. So Rishita and Elham.
Just a minute, sir.
Okay.
Done, sir.
Done, sir.
Yeah. Yeah. So Rishita, did you say done?
Yes, sir.
Okay, now we have the mixed problem. In this problem, what we do is that the ball is thrown upwards and return. Right. So this is this kind of scenario. We have thrown this ball upwards, then it reaches here and then it falls back. Okay. So this is the height, right? And this has some initial velocity u, right? And then it has some final velocity with which it strikes the ground. So let's say this is v. And let's say that it takes t time to reach here. So you guys see that it will take same time to fall back, right? So
Yes, sir.
yeah, so let's write all these scenarios. So we know that h would be what, or u would be what? U would be equal to root 2gh, and this would be equal to, right? And time take or time to reach the height is what? This is u by g, right? So this is, let's say t1 is u by g, or let me write it as t height. Okay. And similarly, t fallback, right? T fallback would be similar. This would also be g, because we calculated this to be v, and v equals to u, so this is also. So total time to come back. Right. So first it goes up here and then falls back. So this would be how much? TH plus TF. Am I correct, guys?
Yes, sir.
So this would be how much? This would be U by G plus U by G. So this is 2U by G. Right. So now let us do one question and it will incorporate all the questions. Right. So let us do that. Is this part clear to you guys?
Yes, sir.
Yeah.
Yes,
So
sir.
please, please note it down. So please note it down. And today's class assessment will be on free fall. Okay. Whenever you guys have noted it down,
Done, sir.
then Elham and Rishita.
Yes, sir.
Yes, sir.
So now let us do a question which will incorporate all these things. A ball is thrown, right, from the ground with, let's say, 40 meter per second. Find time it takes to reach maximum height. Second is that height or whatever distance is they cover in the upward direction, right? So height, let's see height. And the third one is the uh, speed with which it will strike the ground. Okay. And finally, time to go upward and fall back. Okay. So these are the four questions, right? A body is on a ball is thrown upwards. A ball is thrown upwards and it reaches some height, right? With let's say th time in th time and with some initial velocity. Okay, and then it falls back. And it falls back with let's say this is u, and it falls back with v velocity. So we have
Sir,
these.
can we take the approximate value of 9.8 to like 10 meter per second?
Yeah, so whenever in the question that they mention that take g equal to 9.8, so then you take a g equal to 9.8, or you can take also the approximation g equals to 10, right? Yeah,
Yes, sir.
whenever they mention, so, and if they don't mention, then you take g equals to 10, right? Yeah, so okay, so we all know what are these quantity. So time it takes to reach the maximum height, that is th, right? Th is how much, guys?
U by G.
By G. Right. So U is 40 and G is 10. So this is 4 seconds. Right. Second question is what? Height. So you guys tell me what would be height? You guys calculate and tell me what would be height. Yes. So what did you guys get?
Sir, I'm getting negative minus 80 meters.
Minus height is yeah, U is root 2GH, right? So U square is by 2G is your height. So U square is how much? 40 into 40, right? And this is divided by 2 into 10. So 20
8?
and
Sir, isn't it minus negative 9.8 or 10?
yeah, 80 meters. So yeah, you are going in the positive direction. So only all the quantities would be positive, right? Only the acceleration
But
could be, yeah,
yeah, only acceleration will be negative.
yeah. So just because if you try to write out the height and all the things positive and negative, then it would be confused. So only just stick to the gravity part, the G part, right? Then the things would be easier. Otherwise you guys will get confused. Then you will have
So
to,
can't we use the formula H is equal to U square by 2G?
yeah. So yeah, this was the formula. Yes, we can use.
Yes.
I yeah, I forgot this formula, right? I forgot this formula, so I used this one.
Yes, sir.
Yes, Rishida. Did you understand?
So, sir, if we only have one negative, we have to ignore it?
Yeah, we have to ignore. Yeah, so because the distance cannot be negative, right? Right.
Yes, sir, I got it.
Yeah. So 18 meters. Okay, so yeah, 80 meter. You guys got the right answer. And what about the third question? This one is a very difficult question. So the most difficult question, third question. What is the answer, guys?
40 meter per second?
40 meter per second. Right, 40 meter per second. So 40 meter per second. Is that clear to you guys? Yeah. Is this clear to you guys?
Yes, sir. Yes.
And what is the last question? Time to go upward and far back. So total time. Total time in the air. This would be what?
8 seconds.
8 seconds, right? So 4 plus 4 or 2u by g, so 8 seconds. Yes, so this was the mixed question that. So do you guys have any doubt in this question?
So can you show how to do the fourth one?
Fourth one. So you guys saw that the total time is 2u by g, right? Or you can also understand it this way, that whatever time it takes to reach here, it will take the same time to fall back. So TH would be equal to T fall. So TH plus TF, 4 plus 4, 8 seconds. You can do it this way or you can do it at 2u by g. So 2u by g, this one, right? So you can use whatever formula you want. Let me write it as u by g, which is 2 into u is how much? 40 by 10. So it's understood.
Yes, sir.
Yeah, you guys please note it down, and then we'll do one more question, and then we'll understand about the graphs. So yeah, whenever you guys need me to slow down, let's click on it.
Sir, I finished.
You're finished. Oh, okay. So what about Rishita and Amna? What about you guys?
I'm also done, sir.
Done, sir.
Now let us complicate this question further. So what we do is that let's say that a boy is standing on the roof, right? So a boy is standing on the roof, right? And then, so just neglect the height of this boy. And then he throws the ball upward. And then this ball comes in the downward direction, right? So now let's say that the boy throws it with some velocity. Let's say this is 20 meters per second. Okay, and the height of this let's say building is let's say 40 meters. Okay. Now we have to calculate. The question is that calculate the time it takes to reach the ground. Okay, so it goes here and then falls back. So we have to calculate the total time. Is that clear to you guys?
Yes, sir.
Yeah, so what we will do is that you have, okay, so first let us break this question into two parts, right? First is upward, and the second is downward. Okay, so for the upward case, we know that what would be the time, right? This would be u by g. Is that clear, guys? Yes.
Yes, sir. Yes.
Yes.
So 20 by 10, this is 2 seconds. So t upward is 2 seconds. Now we have to be careful with this one. Okay. So for the downward case, let us calculate the height first. Right? How much is the height? So the height would be how much? This would be u square by g. Or what is the height? Let me again. So I always forget this formula. So this is u square is 2gh, right? So height is u square by 2g. Only this much height. Right. This is the height. And yeah, so this is the height. So this would be how much? This would be 20 into 20 and then 2 into 10. So 2 cancel and we have 20 meters. Okay. So this is 20 meters, right? And this is 40 meters. Okay, guys. Now we have to calculate what? We have
The
to,
total time takes to reach the ground.
yeah, so we have to calculate time downwards. Okay. And for that, for that we'll have to do something. So first we need to calculate, we know the total height, total distance we know. How much is the total distance? Yeah, let us write the
60.
60 meter. Yes, correct, correct. Absolutely correct. So let us write the condition. Because we cannot use the previous formula that we have derived, right? Because we have this extra journey. Understood, guys? We can calculate the time that it takes to reach here, but we have this extra journey. So let us solve that accordingly. So condition is that the initial velocity is 0, right? It is dropping from here. So u is 0, s we know, as Rishita suggested, 60, right? So then we have to calculate what? We have to calculate the time. So we know that s is ut plus half, and we are in the direction or against the direction?
Again,
In the direction, right? Amna, how against? We are dropping, right? We are falling. So falling is in the direction, right?
oh yes, sir.
So half. Oh, Alham, you said.
Yes, sir.
Oh, so half GT square, right? This is 0, so this is cancelled. This is cancelled, and this is 60, and this is half, and G is 10, and then T square. Okay, so we are getting a root here. So what should I do? Let me change the equation so that I get the perfect square, right? So let's say that this is 60. I can do this, right? So that I don't bother about the roots. Okay. Then this will also not be a perfect square. How much we should put that it becomes a perfect square? Yes, can somebody tell? Yes. Can somebody tell me that how much we should put that this becomes a perfect square? Any idea that what I am talking about?
Sir, 80?
80, then it would be 100. So 100 and then it would be root 10. Let us, oh, 80, then it would be 16. Yes, 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 yes. Oh, I was right actually. If this is 60, then this is 80, right? 80 into 2 is 16. Yeah, 80 would be fine. So did you guys understand that?
Yes, sir.
Yeah, so I have changed the question to make it easy. Because if I had this 40, then it would have, the answer would be 2. So then it would be, okay, so now we have this 80. So this 10, 10 cancel, and this t square is 8 to the 60. So this is
So T is 4 seconds.
4 seconds, right? So this t downwards is 4 seconds, t upward is 2 seconds, right? So total time would be how much?
6 seconds.
Yeah, t upward plus t down. So 2 plus 4, which is 6 seconds. So is this question, yeah, did you guys understand this question? If you guys have any doubt, you can ask. So only the twist was that we were standing on some, right? So this was only the complication. The rest are, so whenever you find these kind of complications, you just divide the journey. Okay, guys?
Yes, sir.
Yeah, so please note it down, and if you guys have any doubt, you can ask. Amna, clear? Yes, Amna.
Yes, sir.
Okay, so please note it down.
Sir,
Yes, yes.
in the S is equal to UT plus half GT square, why did you strike off the T?
Yeah, UT1, because we have what? Because it is falling down, right? So the speed has become, whenever it reaches the maximum height,
Yes,
so
sir.
then it starts to fall. So it is starting to fall with which velocity?
So 0.
So that's why our initial velocity is 0, right?
Yes.
And yeah, so this is multiplied with t. So 0 into t is 0, right?
Yes, sir. Yes. Okay, sir.
Whenever you guys have completed, take it down.
Yes, sir, I'm done.
Okay, and Ilham and Amna, what about you guys?
Done.
Done.
Okay, so now let us, yeah, so this free fall is completed, right? Now let us go back to the equation of motion. So graphical interpretation or graphical interpretation. So we have how many kinds of graph? We have two kinds of graph for the motion. One is this position time graph, right? And the other one is the velocity time graph. Okay. So we have these two kinds of graph, and always which so in xt graph and vt graph, which one is the independent quantity and which one is the dependable one? Yeah. So in a graph, you have the independent quantity and then dependent quantity. So in xt, in distance and time graph, what is the independent one and what is the dependent one? Yes, Rishita. So in position time graph, what would be the independent quantity and what would be the dependent quantity?
Position would be dependent and time would be independent.
Yes. Yeah, what did you say?
Position would be dependent and time would be independent.
Yes, yes, time, because always time is independent, right? We cannot change time or stop time. So time is the dependent one, so it will come in the x-axis, and the position will come on the y-axis. So this is the xt now, right? And similarly, for the velocity time graph, so this is the independent one and this is the dependent. Okay. Now let's say that a body is let's say that let me talk about graph. I will come to this graph later. So let's say that in velocity time graph, let me draw the data first. So let's say that at t equals to 0, right? At t equals to 0, or let me write this is so at t equals to 0, v is, let's say, u. Or let me write it some numbers and then we will. So let's say that v is 2 meters. Okay, and yes, this is meter per second. This is second. And let's say that t equals to 1 second. This is 4. And t equals to 2 seconds. This is 6. T equals to 3 seconds. This is 8. 4. This is 10, and this is 5 and 12. Right. So when I draw the graph of this kind of motion, so this is t. This is velocity. Okay, and let's say this is 0. This is 1. This is 2. This is 3. This is 4. This is 5, 6. And let's say that I divide this in two parts. So 2, 4, 6, 8, 10, 12. Right. So at 1 it is 2, at 2 it is 4, and 3 it is 6, right? So 8. So what kind of graph I am getting? This is,
Uniform.
yeah, so this represents whenever I have a straight line, right? Whenever I have a straight line in VT graph, so this represents uniform acceleration. Understood?
Yes, sir.
Now let us take this kind of velocity. So I have, let's say this is 2, not 2, let's write it as 6. This is 6, this is 6, 6, 6, and so on. So what would be the graph? The graph would be this, right? So this is what kind of graph? Yes. This is what kind of graph?
You
Non-uniform.
uniform.
Uniform what? And
Uniform acceleration.
uniform acceleration. So this is what?
Uniform velocity.
Uniform velocity, right? This is uniform velocity, which means that acceleration is how much? Right, because the change is velocity is 0. So your acceleration is 0. Yeah, you, who said non-uniform? Allow, you said non-uniform.
Sorry, sir.
You said the non-uniform.
No, sir. I said uniform velocity.
Oh, okay. So yeah. So this is about the graph, and then let's say I have this kind of graph. Okay, so I have just mixed up or messed up the graph. So you guys please forgive me, and you draw the good diagrams. Okay, so meter per second. Let's say that this is 2, this is 6, this is let's say 4, this is let's say 8, and let's say this is 4. Right. So let me choose another. So at 0 it is 2. Okay. And at 2 it becomes 6. So here. So this one is this. And then it becomes 4. Right. So it becomes 4 at 3. And then it becomes 8 at this one. And then it becomes what? At 5 it becomes again 4. So this one, and then let's say 12. So this is which kind of motion? Which kind of acceleration? Yes, this blue one is which kind?
Non-uniform acceleration.
Yeah, so this is non acceleration. Okay, so this is what I was. Yeah, so this is about the velocity diagram. So did you guys understand about all the kinds of the motion that we can have? Yes.
Yes, sir.
So please,
Yes.
yeah. So please draw this graph, and then we'll talk about the derivation. Okay. So let's say that I have this VT graph, and I tell you that this is my VT graph. So can you guys directly say me that what kind of acceleration is this? Yes. What kind of acceleration is this? Whenever I have this kind of VT graph?
Position time graph.
Yeah, uniform. What did you say? Uniform acceleration.
No, sir, I said position time graph.
No, velocity time graph. This is the velocity time graph, and I have this straight line. So this will represent the uniform acceleration, right? Whenever I have this straight line, which would be like this, which will be like this, which will be like this. So all these straight lines represent the uniform acceleration. Can you guys quickly note it down and then talk about the derivation? Yes, I have. Okay, so there is a yeah. So at 0
Yes,
it is
not
2.
so.
So it is starting from here, right, guys? Let me correct this. So this is, let me correct this one. So, because see in this graph it is starting from 1, right? So let me correct this graph. 1, 2, 3, 4, 5. Yeah, did you guys understand this part? I have drawn this graph incorrectly, right? Because I'm starting with this one.
So why
One.
can't it start with 0?
Yeah, but I should have. So this was this. Let's say that this is. So then I'll have to change the graph like this: 0, 1, 2, 3, 4. So then the graph would start from here, right? From here. So 2, 4, 2, 4, 6, and then so on. So this is the graph, right? For this data, because it is starting from 0.
Ah, yes, sir.
So I drawn from here. So this is the mistake, right? Okay, so you guys can just change the graph from here and change this one also. So this one. So it is starting from. Okay, so keep it this way and just change the graph. Yes, Rishita.
Yes, sir. Sorry, I got disconnected.
Yeah. So there's a small correction in the graph. So the graph is starting from 0, right? In 0, you have 2 meter per second. So just change it to this. You just correct to this graph.
Oh, okay, sir.
Yeah, noted everybody. Amna, you also please correct, and Ilham you also correct. Yes, noted everybody.
Yes, sir.
Yes, sir.
Okay, now we can derive the 3 equations of motion. So, but before we do that, we need to know about 2 things, right? So this is the VT graph, and you can see that this is time equals to 0 seconds, right? So this is time equals to 0 second, and let's say that this is time equal to, let's say this is t second. This is 0, this is t. At 0, what is the initial condition that we had? Speed was how much? And at t equals to t, v is how much? These are the conditions, right? So this is u, and this point is what? This is this clear, guys?
Yes, sir.
And yes. Okay. So the first equation is about, and what is the acceleration? What kind of acceleration is this?
Uniform.
Uniform acceleration. Yes. So for uniform acceleration, we have those 3 equations, right? So first thing we needed to calculate is that, let's say that this is A point, this is B, this is C, this is D, and then this is. So first thing is the slope of the graph, right? So slope of the graph. This is how much. This slope is defined like this. This upon this. This is the slope, right? This is CE divided by B, right? And slope of the graph gives you acceleration. Okay, slope of this velocity time graph gives you acceleration. Is that clear to you guys?
Yes, sir.
So CE would be how much? Total is V, and this much is how much? So this is how much? Yes. This is how much, guys? This equal to this, right? So this is how much? Is this clear, guys?
Yes, sir.
So this is U and total is V. So how much would be C?
Sorry, sir.
How much would be CE? Yeah, CE would be how much? Am I not audible? Yes. Am I lagging, guys?
No,
No,
sir.
sir.
Yeah, so I am asking that CE would be how much? Let me write it again. So you have this is this total is V. This is V, and this much,
You.
yeah, this much is U. So
Yes,
I
sir.
am
Yes.
asking that this much would be how much?
V
Yes.
by U.
Oh, so let me draw it like this. This is V, right? And this much is U. And I am asking that this would be how much? Total is V,
V minus U.
V minus. Is that clear, guys?
Yes, sir. Yes.
So this would be V minus. Okay. And this much is how much distance? 0 to T. So this is T. So this is equal to this one. So BE is how much? BE is T. Clear, guys?
T. Yes, sir.
Yeah. So then this is AT and V minus U. So V is U. That's it. This is the first equation that you can have. Is that clear? Yes.
Yes,
Clear,
sir.
guys?
Yes.
Yeah, please note it down, and if you guys have any question, you can ask. If you guys have any question, you can answer. And after this class, you will have the class assessment. So please log into your Learnivio account, and then you will find the actives test, which would be on pre-fall. So the purpose of that test is that how much we have learned. And if you have any doubt, right? So from that class assessment question test, if you have any doubt, you can also ask them. Okay. So noted up to this point, guys. Yes, noted, guys.
Yes, sir.
Yeah. Then, yeah. So noted. Dishta, what about you?
Yes, sir.
Okay. Now let us again the same graph, right? So we have the same graph. velocity time graph. This is the t. This is the velocity, and the initial speed is, this is u, and this is v. So this part, right? Which one would be more? Okay. So this is 0 and this is t. This is VT graph. So area, what is the line? This is the line, right? And the area under this graph is how much? This one is the area, right? Under this graph. So these are the area that it covers, this graph. This is straight line. So let's say that if I have this straight line.
Sir, can you go up again? I didn't copy the last part.
Oh. Which one?
Yes, sir, I'm done. I just wanted to copy the graph.
Yeah. So the area under this graph, so let's say that this is the line. So area under this graph would be this one, right? This one would be the area under this line. And let's say that if I have this line, so let's say that I have this line. So what would be the area under this line? This would be this one. So this would be the area under this line. Okay. Similarly, I have this line. So the area under this graph would be this one, right? Painted in green. Is that clear about area?
Yes, sir.
So in a velocity time graph, what is v into t? Speed into time is distance, right? So area under VT graph is what? Distance covered. So distance covered is, let me write it in this way. So distance covered is how much? Area under the graph. Okay. Now, what is the shape of this thing? Let me write it this as
Trapezium?
trapezium. Yes. A, B, C, D. So area under this graph would be area of trapezium A, B, C, D. So what is the area of trapezium? Do you guys remember? Yes. Do you guys remember the area of the trapezium? Yes. Forgotten, guys. So area of trapezium is half sum of, correct me if I'm wrong, so sum of parallel sides into height. Is this correct definition? Do you guys remember now? Yes.
Yes, sir.
Yeah. So what are the parallel sides? What are the parallel sides?
So AB and CD.
Yeah.
BC.
AB and DC. Yes, correct. AB and DC. And height is how much? This is 40 or this is 80. Right. So you guys tell me what is AB? AB is how much? Yes, AB is how much? This one is how much? U, right?
U.
Yeah, this one is, so U plus B, right? And AD is how much? This is Is that clear to you guys?
Yes, sir.
Okay, so this distance is S, and remember the equation for remember the equation, second equation. S is equals to ut plus half at square, right? So in here, you have ut and v, and the equation that we want to prove is ut plus half at square. So do you have you have u, you have t, and do you have v? Yeah, do you have v in this equation?
No, sir.
So it means that we have to just take care of this guy, right? So we have to remove this guy, and we know the first equation, right? So from here we can remove this guy. So this would be half, and this is u plus at into t. So this is half 2u plus at, right, into t. So let us write this as half and 2ut plus at square. So this would be how much? Let us break these terms separately. So this would be 2ut by 2 and plus half at square. So this cancels, and we have ut plus half at square. So S is ut plus half at square. Is this clear, guys? Do you guys have any doubts?
Yes, sir.
Oh, you have doubts. So what is the doubt, Ilham?
No, sir. I was saying yes, I understood.
Oh, okay. So please note it down, and then we will do the third equation in the next class. So we will do the third equation, and then we also will also start the next chapter.
So can you scroll down just 1 minute?
So you have noted already the upper portions.
Sir, I'm done.
Yeah.
Done, sir.
Okay. So everybody noted.
Yes, sir.
Yes,
Okay, guys. Okay, guys.
sir.
So you guys log into your Learnivio account, and please find the class assessment section, and in there you will find the the active test.
Okay, sir.
Please, yeah, please. Whenever you guys start the test, tell.
So it's showing not available for me.
Okay, not available.
Sir, I can't see it anywhere.
Yeah.
Yes, sir.
Okay, let me ask the learning.
Yes, sir.
Yeah, so it will be activated in just. Please wait up. Yeah, in the meanwhile, you guys can ask me any question. So if you guys have any question, you can ask. Which method was simpler? The calculus one or this graphical one? Yes. So which method did you guys find the simpler one?
It's a graphical one.
Graphical one is the easier one, but the calculus one has had very few steps, right? Okay, whichever method you find,
So for equating the equations of motion, right?
yeah, for the equation of motion, which method you found?
I found graphical easier.
You also found graphical.
Sir,
And Rishita, what about you? Which method?
The graphical representation.
Okay, so all the three of you guys found the graphical one. And yeah, so which was yeah, the calculus method, it was difficult. Which was, yeah. So
the
this method,
graphical one was easier to understand, like the for
oh,
putting the values.
yeah, I can see. Okay, then I will explain these integral one again at some point later. Not now, but at some point later I will explain it. Okay.
Yes, sir.
Okay, let me see if they have activated it or not. Otherwise, what we can do. Okay. Sorry guys for making you wait, but yeah, should have been activated. And I will say I will send you guys some question for this gravity and yeah, and graph one I will not, but for
So where
gravity,
will you send it?
yeah, where?
Sir, on WhatsApp?
Yeah, so the Learnivio team will send you questions. Okay.
Okay, yes, sir.